Hello and welcome to Python Programming Complete course. This is part 16, Stacks and Queues in Python. In this video, we will discuss how to create a stack and a queue in Python using list, its implementation, and what are the application areas of stacks and queues. A stack is a data structure that follows the LIFO principle, that is last in, first out, where insertion and deletion takes place at only one end, that is at the stack's top. In Python, we are going to implement a stack using list. Now it has two operations, push and pop. When we talk about push operation, it means we are adding an element to the top of the stack, whereas pop it removes an element from the top of the stack. So it is last in first out principle which is being followed when we are working with stack. We can also traverse a stack, that is we can it involves visiting each element of the stack and displaying it, that is we are traversing it and displaying the data. There are some technical terms which are associated with stack when we are working with stack. They are peak, overflow and underflow. Peak means we are inspecting the value at the top of the stack, whereas when we talk about underflow, it's a situation where we are trying to remove an element from an empty stack, so it will result in underflow, whereas overflow is a situation which arises when we are trying to insert an element in a stack that is already full. Now overflow situation will occur in other programming languages like C and C++, where we are making use of an array which has a fixed length, whereas this situation does not arise in Python when because we are using a list to implement a stack which is a mutable type and it can grow and shrink in size. So our program, when we are implementing a stack using a list, we will not have an overflow situation. Let's see how we can create a stack. Say we have an empty list which we'll be using as a stack, and we have to add an item to the stack. So we will, since it's a list, we can simply use the append method and add data to it, say 10. So this, we are adding a data. Let's add one more data, say append say 20. So we have added two values to the stack. If I want to display the data, so simply, since it's a list, so I can write print stack, it will show the data. If I run the program, you could see 10 and 20 in the form of a list being displayed as the output. Now but we do not want this. Since we are using the list as a stack, we would like to display the data in a different manner, in the way it is stored in the computer, like 20 first and then 10, because as we already know, the stack is like a pile of book where the data which is at the top, it is displayed first. So let's write a traverse code, a code that will traverse the stack and display the data. So for that, let us first try and find the length of my stack. So we can use the length function, length of stack, it will give me the length. Now let's use the for loop to display the data. For in range, and what will be my range? The top, and then since we are traversing back, since we are displaying the data in reverse order, we'll use -1, top comma -1 comma -1, and at the end let us put a semicolon. And what we are trying to print, we are print one value at a time from the stack. So length of my stack, and then we are displaying the data, but length will be one more because then the values in the stack, because it will start from 0. So what we can do is we can write -1 at this particular position. You could see the data being shown in the form of, like, it is stored in the stack and then it's been displayed 20 and then 10. This 10 and 20 we are getting from this print statement. If I remove it, again save and display, you could see the data in the form of a stack 20 and then 10. Now let us perform the pop operation on the stack. So since we are using list, we can simply write pop. It will remove the last item from my list, and after this, if we print, you could see the data. Let me just remove this from here and print it at this particular position, save and then display. See, this particular data has been removed, 20 has been removed, and what we are getting, we are simply getting 10 as the answer. Similarly, to look for the underflow situation and the peak is like looking at the first value or the topmost value of the stack. We could simply write stack and the top position of, after finding the length, it will give me the topmost value. Similarly, if the stack is empty, we can check for that and print the required statement, whether it is an underflow statement, underflow situation, or some data is present or not. Let's put this together in the form of a program, a complete program with some functions for popping and pushing the items and the underflow and overflow. Let us create the main part of our program, and we have the main, and here we are creating an empty stack. Let's add the code for appending the data. That is, let's define a function for pushing the items in the stack. Say push and stack comma, we are adding an item. So simply we can write stack.append, and this is the item which we are trying to add to the stack. So this is my push function where we are trying to add an item to the stack. Let's call this function, say push stack comma 10, control S. Let's add some more data. Stack comma 20. Let's see what happens. You could see these are the two data which are being added to my stack. Similarly, if I want to delete any item, let's add code for deleting the item as well. That is the pop function. Here we have the code for removing an item from the stack. We have a pop function which is taking an argument, the stack as an argument. We are checking if the stack is empty, then we are printing its underflow situation. Otherwise, we are printing the item which has been removed from the top of the stack. Now my empty stack function, it is checking if the stack is empty. If it is empty, if there is no data in my stack, it is returning true. So in this pop function, if true, it will show me underflow situation, else it will return false, and it will come in the else part where it will pop an item and show me the data. To check this code, let us first call the pop function with the stack, and you could see what is being returned. So it is pop, it is returning me stack empty and underflow situation because no data has been added. It has called this empty function, it has returned true, and it is displaying this stack empty underflow statement. And then these two push functions, they are called, and two items are being added to my stack. If we call the pop function at this time and pass the stack, let's save and again call the same, you could see now items stack is empty, underflow, this pop function is giving me this stack empty, underflow, then 10 and 20 are being added, 20 is at the top of the stack, and this pop function, it has removed 20 from the stack. It has come in the else part and remove 20 from my stack. Now if I want to traverse the stack, same way, first we will check whether the stack is empty or not. If it is empty, then nothing will be displayed, otherwise we will display the data from the stack. Let's write the code for that. So we have a code for displaying the data from the stack. Again, we are checking whether the stack is empty, then it will display this statement, otherwise we are calculating the length of the stack and printing the data in reverse order from the stack. Let's see, let us call the function display. Let's push one more item dot append, push dot stack comma 30. This is the data we are adding, and then display stack. Initially the stack is empty, then 3 items are being added, 10, 20 and 30, and then they are displayed in the order in which they were added in the stack. That is the last one first, then the second one, then the last one, that is the bottom value in the stack. So we have the code for looking at the topmost item of the stack. We have check whether the stack is empty or not, and then if not, then we are displaying the topmost value. Let's display the data. These are the items which are pushed into the stack, and at the top what we got is 30. That is, this is the topmost value in the stack. Similarly, here I am manually forcefully calling these functions. You could write a loop, a for loop or a while loop. You can create a menu, and then using that menu you can display the data as per the user's choice, whether they want to add or remove the data from the stack. For that you will have to maintain a top pointer which will always point to the top of the your stack, and accordingly you can move it around to display the data. Now, what are the application of stack? It is used in evaluation of arithmetic expression. We have already discussed during function calls and recursion, stack is being maintained. The undo features in computer keyboard. It is used in backtracking algorithms. It is used for reversing the data or reversing a line or a string. Then the back button in browser, the back button which we have in the browser, it also save all URLs which we have visited. We can click on the back button, so we can go back to the previous web page. There also stack is being used to maintain that list. Let us discuss what is a queue. A queue is a linear list which follows the FIFO principle, that is first in first out principle. It has two ends, the front end and the back end, and it is open from both the ends. There are variations of queues which we will discuss. Now the elements are added at the rear end and the deletions are done at the front of the queue. Adding a data or adding an item to the queue is known as NQ, whereas deleting an item from the queue is known as DQ. Here also we have three technical terms: peak, overflow and underflow, and we will be implementing the queue, the program which we will be working on. We will implement the queue using a list. So our overflow situation will not arise. We will definitely look into peak and underflow. So here let's quickly create a queue using a list. Since it's a list, we can add the data using append method. Anything same with the with the stack which we have created earlier. We can have a queue as we are adding to data. If I display my queue, print queue, let's save and print, you could see in the form of a list 10 and 20. Any data which will be added, it will be added after 20. Any deletion which will take place, it will be done from the front of the queue. So if I want to delete anything, I'll not simply write pop. What I will do is we will provide an index from where we want to delete the data. Say pop and 0. If I write pop 0, so it will delete the data from the front. And again, if I write print queue, save it and print it, you could see the difference. 10 and 20, they are being added. We have printed the queue using the print. I have deleted 10 and only 20 is being left in my queue. To print this data in the form of a queue, like earlier we did for stack, we can traverse the data in the queue and print it. Let's write the code for printing the data. Same 10 and 20 if they are here. Let's add some more data. Queue dot append, say 40, and if I write for I in range, we are starting from 0 and we are going till the length of the queue. And what we are doing, we are printing q and I, the first value from the queue, and we want it to be in the form of a line. So I am writing, I want spaces one after the other. Let me save it and print the data. This time, instead of a list, what we are getting a queue of numbers 10, 20 and 40. Similarly, we could, the earlier like we did for stack, here also we can add different functions. We can have NQ, we can have DQ, we can check for overflow, and we could write a function for traversing. Let's see that program, then we will discuss the different types of queues and the application of queues. So we have a main program where we are creating a queue. Let's add some data for adding item to the queue, that is the NQ function. So we have the NQ function where we are passing a queue and the item, and we are adding it to the queue, and it will show me what data is being added to the queue. Let's add the DQ function to delete the item from the queue. We are removing an item. We are checking if the queue is empty, it will show me underflow. Otherwise, from the front we are deleting and we are removing an item from the queue. Let's write the empty function as well. So this is my empty function. We are checking whether the queue is empty or not, and accordingly it is returning true and false, and it will print whether true or false. Let's check this much part of our code. let's call the enqueue function, pass the queue with an item, say 45, enqueue, this is my queue, 55, and save it. Let me run it. 2 items have been added to my queue, 45 and 55. Let's delete an item from the queue. First let's check dq and queue. Let's check first. You could see queue is empty. It's resulting in an underflow because nothing is being added. Then we have added 45 and 55. You could see I'm not removing the results. You could see the output. Now again let's call dq. This time let's see what will be printed. Underflow. This is giving me an underflow statement because no data was there. Now we have added 2 items, 45 and 55, and then calling dq with the queue, with passing the queue, it has resulted in removing the item from the front. 45 is being removed from my queue. With queue also we have the peak term where we look at the item, the frontmost item from the queue. So we have a code for that, a function where we are looking at the firstmost item, the front item of the queue. You could see this code. If I run this program, we'll get the front of the queue. Let me remove this enqueue and dq and add peak queue, save it, run the program. 2 items are pushed to the queue and the item in the front of the queue is 45. Let us add some code to traverse my queue. Let's add some code for that. So this is the code for displaying the data from the queue. We are checking whether the queue is empty or not. If it is empty, we are printing a statement queue empty. Otherwise, from the beginning to the end of the queue, we are displaying the data. Let me save and display. Let's add some more data to my queue. Enqueue queue, 67. Save and then let's print. You could see 3 items are being added using the enqueue function, and then there are these items in my queue. Similarly, you could create a menu for calling these functions as per the user's choice. That can always be created. Now there are 2 types of queue which we will discuss in this video. Circular queues, which are implemented in a circular form to utilize the space in when we are having a fixed size linear queues like in C and C++, where we are using an array which is of a fixed size, and if we delete an item then empty spaces are being left. So to utilize those spaces we implement a circular queue. But since we are using list to implement a queue, we will not be using it in Python, because we can always expand and shrink the size of the list. The other one is dq, or the double-ended queue, in which elements are added or removed at either end of the queue. They are also the double-ended queue. They are also of 2 types. Let's discuss what are the application of queues. Now the first one is resource sharing among users. Like if on a network, if we have a printer and different users are using that printer, then we implement the queue, and one by one it is that resource, that printer is being used by the users. In CPU scheduling and disk scheduling also, a queue is being maintained, and then accordingly the work is being done. Now queues are also maintained in routers and switches. So there are various practical implementation where stacks and queues are being used. This is just a small example using a list how we can implement a stack and a queue. So in this video, we have discussed what is a stack and a queue and how to implement a stack and a queue using a list in Python, and what are the application areas of stack and queue. Hope you found the information shared in this video useful. Stay tuned for upcoming videos, and thank you for watching.